All systems check. Welcome to the edge of the world. That deep orange gradient you see isn't just a sunrise. It's the physics of Rayleigh scattering in action. We are looking at the Kármán line, the physical border of space, sitting just 62 miles, 100 kilometers above the surface. That thin blue line is the only shield protecting life from the absolute vacuum. We are pulling back, fast. Look at the northern hemisphere. That vibrant green crown is the aurora borealis, essentially a planetary-scale neon sign, lit up by solar winds slamming into oxygen atoms 60 to 400 miles, 96 to 640 kilometers up. As Earth shrinks to a sphere, notice the moon. It looks close, but it's actually a 238,000-mile, 384,000 kilometers hike away. Say a goodbye to the sun. As we hit escape velocity, our home star shrinks until it's just another speck in the dark. We are crossing the Great Void now. For context, Voyager 1 is over 15 billion miles, 24 billion km out. Yet the next nearest star, Proxima Centauri, is still a staggering 25 trillion miles, 40 trillion kilometers away. The scale here is terrifying. And here it is, the grand reveal. You are looking at the Milky Way galaxy from the outside for the first time. It's a cosmic city stretching 100,000 light years. That's 588 quintillion miles across. Those spiral arms aren't solid structures. They are density waves, massive traffic jams of gas that trigger the birth of bright blue stars. We're orbiting the galactic disk now. See those smaller blobs trailing the main galaxy? Those are satellite galaxies. Like the large Magellanic Cloud, sitting about 163 light years away. They're caught in a gravitational dance, slowly spiraling in due to dynamical friction. Eventually, our galaxy will rip them apart and consume them. Focus on those dark scars cutting through the light. That's not empty space. That's interstellar dust. These clouds are composed of silicates and carbon, freezing at minus 400 degrees Fahrenheit, 240. They block the visible light from the core. But inside those dark lanes, new solar systems are being forged right now. From this angle, you can see just how razor-thin the galaxy actually is. It's 100,000 light-years wide, but only about 1,000 light-years thick. Why? Conservation of angular momentum. Just like a chef spinning pizza dough, the massive gas cloud that formed our galaxy flattened out as it spun faster and faster. We're diving back in, targeting the galactic halo. This structure emerging from the dark is a globular cluster. It's a gravitational ball packing up to 1 million stars into a region just 100 light-years wide. These are the ancients, stars that formed when the universe was young, long before the disk we just left even existed. Welcome aboard. We are currently drifting through a stellar nursery about 440 light-years from Earth. This is an open cluster, likely the Pleiades, spanning roughly 15 light-years. That's 88 trillion miles, 142 trillion kilometers across. You see that blue haze? It's not leftover material from star birth. It's actually starlight scattering off a dust cloud these stars are just passing through by chance. But let's leave the nursery and find the heavyweights. Dead ahead is a blue supergiant. This star is a monster, packing 20 times the mass of our Sun, with surface temperatures scorching past 50,000 degrees Fahrenheit, 27,700 degrees Celsius. It's burning its fuel so fast it'll be dead in a few million years. Unlike our Sun, which has billions left, That rainbow halo? That's just raw photon pressure overwhelming our sensors. As we swing around into orbit, notice how empty the immediate vicinity is. This star is pumping out energy at a rate 100,000 times greater than Sol, blasting particles outward at 4 million miles per hour, 6.4 million km/h. It's literally blowing a bubble in space, ionizing gas and clearing out any debris. It's beautiful, but you wouldn't want to live here. Hold on. We're picking up a massive gravitational anomaly. That is a supermassive black hole. See that orange ring? That's the accretion disk. Matter swirling in and heating up to millions of degrees due to friction. And that blue beam? That's a relativistic jet-launching plasma at 99% the speed of light, before it can even fall in. We're getting closer. Look at how the light warps. The gravity here is millions of times stronger than Earth's, bending light so severely, we're seeing a funhouse mirror effect called gravitational lensing. You are literally looking at the back of the accretion disk, bent up and over the top of the black hole's shadow. The event horizon itself is likely 100 million miles, 160 million km wide. Brace for entry. We are flying directly into the relativistic jet. It looks like a wall of light, but these are magnetic field lines channeling superheated plasma. The energy per particle here hits billions of electron volts. We're seeing extreme blue shift now as we race into the path of high-energy photons. This is the cosmic highway. Visuals are breaking down. We're approaching the singularity, a region where tidal forces are so extreme they'd stretch you into a strand of atoms. A process literally called spaghettification. The curvature of space-time here is becoming infinite, and the classical laws of physics we grew up with, they don't apply anymore. And there it is, the event horizon. That dark sphere is the point of no return. The ring of light surrounding it is the photon sphere, where gravity is so intense that light itself is trapped in orbit. To escape this boundary, you'd need to travel faster than light, over 670 million miles per hour, 1 billion km/h, which is physically impossible. We are home now. Welcome to the ultimate road trip. We're starting right here, at the edge of Earth's atmosphere. But we aren't staying. Buckle up, because we're about to break every speed limit in the universe.